Okay, we're live. All right, so taking these little properties down. What did we say before? Mod math is what? What's one word that we say when we say mod math? Remainder. So you're looking for remainder. All right. First two properties, I actually kind of talked about this yesterday. One is simple. A equals A mod M. That's kind of self-explanatory, I think. But the second one, I did kind of say that at least hopefully in most of the classes, if I have A, B mod M, that's the same as B, A mod M. You could switch them around. You're really doing mod of both the numbers anyway in that congruent statement. And because of my computer program doesn't have this when I type, these are all, and you saw that in your book yesterday, right? The three-lined congruent sign in your questions, correct? Anyone? Everyone's looking at me like I'm an alien, right? Okay, and it wasn't really a squiggly like you saw congruent signs when you did, let's call it math 2, not geometry, all right? The third one gets into what we're going to be doing today. And then all you have to do is exercise the property and then, analyze remainders and all that and go from there. So what I wanted you to understand, though, this last statement, 3, if A equals B mod M and C equals D mod M, then this is the case, which really means this. Let's replace A with B mod M. And then let's replace C, which my arrow now is invalid because I wrote too large there. C mod M. I'm sorry, D mod M. My bad, dogs. Roof. And that equals B plus D mod M. So what that means is, what's the matter? Is everything okay? It's oh, jeez, Louis. Excuse me, sir. I froze the screen in class so students have no idea what I'm talking about because I'm talking about things that they don't see me writing. And again, I write like a kindergartner because this new computer is very hard to write on. And all the teachers are complaining about this, so it's not just me. Okay, so what this means is if you saw B plus D mod M, you could mod M both of these separately and then go ahead and add. Okay, so you maybe not know what I mean there. So we'll do the first one. Actually, we'll do all of these when I show these properties. Exercise them with numbers, and we'll do it two ways. Now, I hope you understand yesterday I did a couple of notes where I said you could do this way or that way, make a choice. All right, well, that's the same thing here, but there's a little wrinkle in this. One way implies that I'd make you do it without a calculator, and there may be no calculator parts to the quizzes and or tests. This is an honors math class. I expect numeracy. I expect you to know your times tables up to 12 times. What's 12 times 12, everybody? 144. What's 11 times 11? 121. And then any 12 times any 10 times, division rules by, 5, and you should be able to handle that stuff. And then the adding kind of stuff and dividing. So making you think numerically in this honors class. So here's method 1. How do you evaluate 54 plus 67 mod 3? Potentially a calculator, but I don't know. That's random. What you could do is go ahead and add these. And what I don't like about the mod formula kind of situation is technically I feel like there should be parentheses there. What you're doing is modding the sum. Okay, that's not 67 mod 3, get that answer, and then add that to 54. You understand what I'm saying? And I find that problematic with my cat, meow, brain, college algebra trig, use of parentheses and all that other stuff kind of loosely. So you're modding the sum. You're not modding 67 and then adding that answer to 54. Be aware of that. Okay, so one way is just to add these two. 67. Is this 121? Is that right? Okay, mod 3. And then why would this be a calculator? Maybe two reasons. The sum is large, although you could go off to the side and grade school it. Put them above and below each other and add the columns and all that other stuff. And then maybe mod 3ing 121 might be tough. But I don't think it should be. Does anyone know division by 3 rule? Like, is this 0? If I mod 3, 121, is this 0, yes or no? Does 3 go into 121 evenly is what I'm asking. No, why? What's the rule? You said yeah. Were you lying? You were lying? You lied. You just lied to a teacher. You said you knew the rule. Does anyone know a divide by 3 rule? Let me pause the video because this isn't going very well. The divide by 3 rule is when you add the digits together, if the sum of the digits is divisible by 3, then so is the number. Wild, right? But it's even crazier now. What's 1 plus 2 plus 1? 4. How far was it off from being divisible by 3? 1. Guess what? This is equal to 1. Mod 3. So what we did is we analyzed it and got an answer for it by doing this rule. Now I can prove it. What happens when we actually physically divide 121 divided by 3? Oh, because no one helps me, right? 40, 80, 120, right? This is 40, 80, 120. This is 40 and 1/3 when you divide this. Okay, right? 3 times 40 is 120. So that means I have 1 left over, 1/3. Put that Chromebook away, man. Unless you're taking notes. Are you taking notes? No, you weren't. All right, good, nice. Caught a student online. Got a liar and a Chromebooker so far. Okay, so, I'm just saying. You okay? All right, the next way is, I would call this the no calculator way. So it goes down to this one, how I rewrote this with my chicken scratch there. I have B plus D mod M. What I could do is separate those and mod M each part of the sum, find out what that answer is, and then add those together. So method 2 would say, okay, I have this question. I'm even going to write it that way. I could go ahead and mod 3 each one of these. And then, oops, forgot 67. Mod 3 each one of these. And then add the answers after. So 54, what's 5 plus 4, everybody? 9. Does 3 go into 9? So 3 goes into 54. Actually, 3 goes into 54 18 times. 30, 8, 16, 24. But mod means remainder. So the remainder of this is 0 mod 3. Plus, so you're replacing that with the smallest number that shares the same remainder as 54 when divided by 3. And then 67, what's 6 plus 7? Now we can play this game. 13. Again, this is only 3. People use these division rules for other numbers. You're bogus. Only 3 has this special property. Actually, it's a lie. There's one more. What other number has a special property of division? Well, yeah, that's true. 5 ends in 0 and 5. But no, one that's like 3. 9. Okay, 9 has the same rule, and you'll see that when we build into this. But what's 6 plus 7? 13. Does 3 go into 13? 3 goes into what, though? 12. So how far off on this sum? 1. So this is actually 1 mod 3. That's another speciality of this. Okay, now when I look at 67, 3 goes into 66. I think we should easily figure that out. 3 goes into 66 with a remainder of 1. So this sum rule is special now for mod math as well. And I hope you get that. And now what's the final answer? Just like we had up here, 0 plus 1. You could turn this into 0 plus 1 mod 3. And that's overwritten. You can just jump to that, which we already got the first way, and I just told you there's 2 ways of doing this. But I think in your homework it says do both ways. And in my quiz on Thursday, I think I will say do both ways. Scratchy. Well, I'll blabber on the video as first hour's writing. Looking at example 2, it says mod 7. Does 7 have any special division rule that 3 does? Yes or no? No. Okay, and I know you may be, I'm not sure, because I didn't even know the 3 rule. I didn't remember that. Only 3 and 9 have a special division rule that you can add up the digits like this and do that. And that's it. Someone said 5 has a special division rule. I mean, yeah, it's not the same, though. If a number ends in 5 or 0, 5 goes into it. 10, if a number ends in 0, 10 goes into it. Not the same as 3 and 9, though. 3 and 9 have this weird anomaly, I guess. This weird situation that actually weirdly ended up being true. So back to this one, really what the rule is, if I have b times d mod m, that's the same as b mod m. And then anyone that was in CAT last year, what I'm doing is just replacing a with b mod m. See, a equals b mod m, or is congruent. Sorry, lack of, the congruent sign for my typing. Times c is d mod m. And what this says is, if I have b times d mod m, I can mod m b and d separately and then multiply the answers. That's what it means when we put all the properties together. So again, you have two ways to analyze this. I guess I'll stay right here. One way implies that we're going to use the calculator. And that implies that we'll do the first way, where what I really can do, I don't know why that's not staying. All right, what I can do, maybe I'll put a congruent, is multiply 16 times 31. Can someone do that for a fella? That fella being me. Okay, so with a calculator, we can just go ahead and multiply those two, and then mod 7 that. Calculator again. What we do off to the side is 496 divided by 7. Tell me the decimal, just to piggyback off what we said yesterday. No, what's the whole thing? No, just to get... No. What's the number in front? The whole number. 0.857, blah, 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 blah. Then what do we do with that 0.857? What did we do yesterday? We take 0.857 and multiply it by what? 7. Did you do it? Can you do that? Really? 6.0000? It's going to be 6. I probably could have guessed that. So what's the remainder? What's the remainder? 6. So this is 6 mod 7. So 16 times 31 actually gets knocked down to 6 mod 7 because 496 has a remainder of 6 when you mod 7 it. So these are equivalent. So what you've done is reduced it or simplified it, I guess would be the math term for this. Or you could do this. I don't know why that's it. Y? Won't the Y? Did you see that? Did you see that keep disappearing as I wrote it? Okay, he's not looking. He fell asleep. Now I got a sleeper. All right, what you could do is this. 16 mod 7 times 31 mod 7. Who's having fun so far? Is everyone okay? We have a question? Hold on. Okay, and I should ask students, you know what? I got a lot. I'm behind on the stamping. I got to get your papers back. So this is formal, illegal, non-common core notes. But everyone, how many times does 7 go into 16 without going over? How many times? Twice, and then what's left over? So this is why this is a no calculator. Everyone should be able to figure that out. Everyone should be able to figure out that this is 2 mod 7. Isn't that weird? Mod math is crazy. It's just like 1,400 hours. What's 1,400 hours actually on our clock? What time is 1,400 hours military time? 2. Because after noon, which is 12 o'clock, then it goes back to 1, 2. So that's the same idea. 1,600 hours. Well, no, that's not right, because that's a mod 12 system, not mod 7. Anyway, I'll shut up. All right. What's 31 mod 7? How many times does 7 go into 31? 4. What is 4 times 7? 28. So what does that leave? 3. Then you can see why this is getting the same answer. What you do at the end is then use this rule that if it's this and that, then you reverse it. This is the same as 2 times 3 mod 7, which is 6 mod 7, which is the exact same answer you got when you multiplied them out in the first place and then just use your calculator. But we didn't need our calculator. Those were small enough that we could analyze those mods without it. So that's the point. 2 different ways. One is, I think, a little bit easier because it's less, you don't need your calculator and you can analyze them. Oh, I think I hit start. Is it going? Yeah, things moved on me. So far, I'm doing pretty good, though. I haven't closed any documents, haven't opened up other things. Touchscreen. It's really the second one. Now, all right, here we go. Get ready for some real math here. Some not real math. Some your first probably big stretch mathematically. As this gets a little bit complicated. I have 3 of these examples with exponents, and they ratchet up as we go. They get crazy. Okay, so if A equals B mod M, then A to the K equals B to the K mod M. That just means if A equals B mod M, if I raise these to the same powers, we still have equality, or actually what I should say is congruency. Okay, whoops. All right, and then this example is not too bad. The next 2 requires, I'm going to help you on, what we can do to make this simple, although we need to know our exponent rules from Math 2 and Math 3. Okay, we're going to need to, maybe I'll write them off to the side, but I'm jibber-jabbering a little bit. The first way to do this one is you don't even need 6's rule. All you need to do is take 2 to the 10th. I believe I remember, can you do 2 to the 10th real quick? My calculator guy here, the one that's helped me out. I think it's 1,024. Of course I'm right. Now, this requires no rule. I could have given this yesterday in your homework. You may have frozen. Wait a minute, he didn't talk about exponents. Oh, well, what if I just take 2 to the 10th? Oh, that's just a number, 1,024, and then it's a big number, so big numbers usually mean calculator. Go for it. Tell me the whole thing, whole number plus decimal. 0.2857. I'm guessing that's going to be 2 over 7. But go ahead and take 0.2857 blah times 7. And then this is 146 and blank sevenths. It's probably 2. 1.99, 2. That means this is 2 mod 7, and you're done. So that required no properties up there. Nothing whatsoever. You're fine. Okay? Now again, remember, it's all about remainder. So that's what weird mod math is. Just want the remainder. 1024 mod 7. What number between 0 and 6 has the same is the same as the remainder on 1024 when divided by 7? I don't know if I said that perfectly, but okay, now this is where you got to put a star. I have to know how to do this. I have to know how to do this without a calculator. It's my job. So what I might put off to the side is, what's x squared times x squared? What are you supposed to do? That's probably a bad. Let's put third. What's x squared times x to the third? Just so we could see that. What do I do with those exponents? This is the rule that you have to know. What do you do with these exponents? You add them. And it really is, it's silly to have a rule for this because, this is x times x. This is x times x times x. There's 5 x's being multiplied together. That's why you add the exponents. Think about it sometimes if you're thinking about multiplying those exponents. That's the other possibility. That's a completely different rule. So here's where the abstractness comes into play. It was 2 to the 10th. Why did I make it 2 to the 5th times 2 to the 5th mod 7? And the reason you want to do that is you break up the exponent. I mean, you have choices. You could have done 2 to the 2nd, 2 to the 8th, but do you know what 2 to the 8th is? No. Or it's bigger. But, if I break down 2 to the 10th to 2 to the 5th times 2 to the 5th, all I have to do is analyze 2 to the 5th and use your fingers. What's 2 times 2? Look at my fingers. You can't online. I have my fingers up in the air, 2 of them. What's 2 times 2? Let's do it again. What's 2 times 2? 4. What's 2 times 4? What's 2 times 8? What's 2 times 16? And we're done. 32. So each one of these is 32. Now, I'm not going to write this every time like this, and I don't expect you to do this. What the beginning, I don't know what number the rule was, but what the rules in the beginning is how do I mod this product? Well, what I could do is mod 7 each part of the product and write those down. Okay, fine, I'll write it. How to analyze this from whatever rule number it was? I can mod 32 and mod 32. I can break this up. That's what that one rule that I had up there. I don't know what rule it was. Fine, I'll go up to it. I think it was 4. Yeah, that's rule 4. When I put the b times d mod m is b mod m times d mod m. I can mod each part of the product and then analyze. All right. Okay, how many times 7 go into 32? Oh, no, this is going to be weird. 4. Okay, and then what's left over? 4. So this is 4 mod m, or mod 7, sorry. And then what's that make this? 4 mod 7. So you only had to think once and then put the answers in there twice. And then what am I supposed to do with the 4s? Not add them. Multiply. What's 4 times 4? It would have been add if it was the add rule. This is the multiply. What's 4 times 4? Oh no, well, this is going in circles, or am I done? Have I reduced this all the way? No, now all I have to do is what's 16 mod 7? How many times 7 go into 16? Twice. What's the leftover? Okay, so we did this without a calculator. It did require a couple steps, especially the weird thing that happened at the end. But it's all okay. Nothing really blew your brain apart. The worst thing you had to do was know your exponent rules and make this choice, I guess, and then analyze what 2 to the 5th was, and then use the properties. So I don't know what else to say about that. That's what we're trying to get you to do. Why this requires method 3 is, first of all, go ahead and type, let's try to do method 1 where, I have an exponent. Let me just type that in my calculator. So type 2 raised to the 302nd power. Not gonna do it. Overflow? And then it's E what? 98th. E to the 98th power. What? All right, and then you got to analyze when I divide by 7. This is, did you hear that? My phone's on, sorry. Okay, there's this little text or something. I have friends. All right, this gets too large and you can't even use method 1. You can't even use the calculator for this. To even analyze what the decimal is and then analyze what the remainder is. That's number 1. Number 2, break it down to what's half of 302, 151. 2 to the 151st is too big. So you're stuck. You are really stuck with doing what I'm going to show you next. So the key is what you need to do is right here. You need to find a value within a power of 2 that is equal to 1 mod 7 in this case. So you got to do a little side work and then work with your exponent rules. And now we are going to do the exponent. Here's the exponent rule we need for this one. What's x to the 2nd raised to the 3rd? What do you do with those exponents? You multiply them. So that's the rule we're going to use on this after we do our side work of, what power of 2 gives me 1 mod m? And the reason I want that, what's 1 times anything? What's 1 times anything? The thing, whatever it is. So that's why I want 1 mod m. So let's go off to the side. What does 2 mod 7 equal? What does 2 mod 7 equal? How many times does 7 go into 2? 0 with a remainder of what? 2. So there's no big deal there. This is 2 mod 7 equals 2 mod 7. I can't reduce that. Okay, so what's 2 to the 2nd? What does 2 to the 2nd become? 4. What is 4 mod 7? Can it be reduced? Yes or no? How many times does 7 go into 4? 0. What's the remainder? 4. What am I looking for? Say it one more time. 1 mod 7. Okay, so what's 2 to the 3rd, everybody? What's 2 to the 3rd? 8. What is 8 mod 7? Oh my gosh, what's 8 mod 7 actually equal to? How many times 7 go in 8? You're killing me, Smalls. 1. And then what's the remainder? 8 mod 7 is equal to 1 mod 7. So ultimately, 2 to the 3rd mod 7 equals 1 mod 7. This is the jackpot. This is what I'm going to use. I am going to change this power to 2 to the third and then work with my exponent rules to see what's left over. Keep it equivalent to the 302nd power. So here's the beginning. I'm going to raise this, or I'm going to make this 2 to the third. All I'm doing is rewriting 2 to the 302nd power. Okay, and then the first rule I'm going to use is 2 to the third raised to something so that it's close to 302, if not exactly. All right? Okay, what's 3? Now, I know this isn't mod math, but this is just figuring out how do I work my exponent rules. 3 goes into what number that is very close to 302? 300, right? Right? Okay, so 2 to the third raised to the what makes this 300? 2 to the third raised to the what makes this 300? 100. I don't know why that's happening. Okay, so let's analyze this real quick, and then I'll show you why we did what we did. And then I'm going to kind of use some rules. That's not a 160, sorry, this is a 100. Right in like my chicken scratch there. Do you analyze that this is 2 to the third raised to the 100? It's only because 2 to the third mod 7 equals 1. And this is really going to reduce this so fast it's going to be ridiculous. And then I'll show you some couple of the rules put together, what we can do right in here. But my next question is, what's missing? How much of the power are we missing? 2. So what do we do about that? Times, we use our rule up here. So 2 to the 300 times 2 to the second, you have to understand is what? What do I do with those exponents when I have 2 to the 300 times 2 to the second? I add them. So all I'm missing is another 2 to the second power. This is 100% equivalent then to this. And what I've done now is I've got it in a position to really simplify this fast. Okay, mod 7. Now, we're going to use the rules liberally, and you don't have to keep rewriting these things. Okay, when I have mod 7 of a product, I can mod 7 each part of the product, right? So now that you know this is 8, and it's raised to the 100, not only can you mod 7 each part of the product, you could mod 7, 8, reduce that answer, and then raise that answer to the 100th. That's another use of our rules. That's that exponent rule. So what is 8 mod 7? We already know that. What is 8 mod 7? 1. And you don't have to keep rewriting this. But what's 1 to the 100th power? Isn't this wild? What's 1 to the 100th power? 1. And lo and behold, we have our answer. Because 4 mod 7 is the most simplified answer for this. So you don't have to keep writing a product. Mod 7 is mod 7 of each part of the product. You can just go ahead and, okay, I got a mod 7 this, I got a mod 7 that. Well, that one's already done. This one, 8 mod 7's 1. Then I can raise it to the power. And that's why we search for 1 mod 7. We did our side work here to find out which one equals 1 mod 7. And then we got it in there so that our simplification is going to be really fast. Okay, any questions? You don't have to. Hey, it's a free country. So you can watch this. All right, so more of the same. You look shell-shocked, you all right? Okay, this is for added fun. It's more the same with a different little, it's up here, the notes. More of the same with a harder number. Harder number. And then mod 20. Mod 20 is pretty large. So it's the same old thing. I can't say your name online. That'd be illegal. The student over here that types the things for me very nicely. 3 to the 203rd. Might even say calculator overflow. That means it's too big. I can't do it. Or the answer's indiscernible. You wouldn't even know what to do with it. Mod 20ing it and not be able to read the answer. So off to the side. 3 to the first mod 20 is 3, right? What am I searching for, by the way? What do I want these to reduce to? I don't know why that's happening. What do I want in front of mod 20? 1. What's 3 to the second? I got it. It's 9. Wow, we're in trouble. Mod 20. What's 9 mod 20? Just go ahead and say it. 20 goes into 9 how many times? 0. What's the remainder? 9. Not good. What's 3 to the third? What's 3 to the third? 27 mod 20. What does that become? That does reduce. 20 goes into 27 how many times? Once with what? So I can stop writing these. You don't have to write them all out if you know they're not going to work. Oh my gosh, this is ridiculous. What's 3 to the fourth? What's 3 times 3? What's 3 times 3? Okay. What's 3 times 3? What I just did there, I did 3 squared and I did 3 squared. What's 9 times 9? Is it really ridiculous? Because what's 81 mod 20? What's 81 mod 20? 20, 40, 60, 80. What is 81 mod 20? Boom. Anyone? Shaka. Anyone? Laka. So instantaneously you take 3 and make it 3 to the fourth. And then you start using your exponent rules. You can do this one of two ways. All I need to know is, what should I raise 3 to the fourth to so that I get it close to being 203? I bet you many could figure that out already. 4 times what equals close to 203, as close as I possibly could get? 50. What's 4 times 50? 51, 52. So this could be guess and check. This would still be a calculator question, by the way. Okay, this would not be in the no calculator part. Not be in the no calc part. So you can play with numbers using the exponent rules and understand that this is 4 to the 50th. I'm sorry, 3 to the fourth raised to the 50th. So what's 3 to the fourth raised to the 50th? 3 to the 200th. What am I missing? How much am I missing? How much power? 3 to the what? 3 to the what? Third. Now, what you need to understand is this. You can go on this fast. Okay, so what's mod 20 of 3 to the fourth raised? What's 3 to the fourth mod 20 then? What's 3 to the fourth mod 20? It's actually what? 1. And then what's 1 to the 50th? I don't even care if you didn't write all of this. Actually, we're going to write this. 1 to the 50th is 1. 1 times 27 is 27 mod 20. And you actually already did this. What was 27 mod 20? It's off to the right. We already answered it. What's 27 mod 20? 7 mod 20. So again, all this goes back to what we said yesterday at the very end of the notes. I said sometimes, and I said, no, change that word. All the time, or a lot of times, when we mod m, we want the answer that's smallest between 0 and m minus 1. So that's what we're doing here. We're simplifying this down. But in this case, we're using fancy little exponent rules.